This lesson is going to focus on developing the circle area formula. Instead of giving it to the students, we're going to see why it makes sense and how it relates back to base times height. So what we're going to be using are fraction circles. So this is the full circle, and all the pieces that we're going to be using today will fit on this circle. Now, just a point of interest, eventually this unit moves toward central angles in circles. If I take a look at these quarters, I know all of them have a 90-degree angle. If I put 4 90-degree angles together, I have how many degrees in a circle? 90 plus 90 plus another 90 and another 90. 360. That's something that we'll develop a little bit later. So you are going to need some masking tape. So if you can give the students a strip, this is the sticky side up and these two are just holding it down. And we want to put our circles together because when we cut up a pizza, we still have the same area of pizza, right? So if I can break it down, and arrange it in a different way, will I still have the same area? Yes. Now, when we did our original area lesson, we talked about a parallelogram. Well, right now, it doesn't look like a parallelogram. It looks like the Very Hungry Caterpillar. Now, you also need to be working with the even numbered fraction block. So this one has 6, our last one had 4. So now we're starting to get the slant of the one side, but we still have a few arcs on the edge that we don't want. And this is when our circle is divided into 8s. So it's getting closer to our parallelogram. And the more sectors that I cut out of my circle, the more it looks like a parallelogram. So if I take this so what I could do, move this a little bit closer. I can draw a line and oops. And maybe I'll just put a mark here. Straighten these out a little bit. Now we can see this is base times height. So if we take our fraction piece, here's our height. What was that as part of our fraction circle? Well, it's going from our center to the outside edge. So the height is the radius. Now if I took all of these little pieces off and put them back on to my circle, remember, these were the outside arcs all the way around here. So what did we call that? The circumference. So the circumference goes on the bottom base plus on the top. So in other words, if the entire circumference is both, we can say half of the circumference is down here. Now this gets back to how we talked about all these terms are interrelated. What did we use to find the circumference? Well, it was pi times the diameter. Or we could say it was pi times 2 radii, or radius. So if the whole circumference is this, I want half of it. So I could say this is pi times 1r, and this is pi times r, because I know 2 of them will equal my diameter, and my pi stays the same. So if I want to develop my base times height, I have pi times 1 radius times another radius, or pi r squared.